In the name of God. Hello, dear students. Welcome back to Fairqua's website. My name is Masood. I'm a physics teacher. We are here in this website to explain physics curriculum. Our goal is make the physics easy for you as much as possible. Also, we have an application by the name of Fairquas. You can download it on Play Store of your cell phone to watch and follow our videos. So far, I explained one subject from chapter one, uh, grade 11. I explained the motion. I'm gonna jog your memory uh, by reminding the definition of motion. So what's the motion? Motion means changing position of an object from starting point to the ending point, from initial position to the final position. This is called motion. And I told you motion is associated with any creature, whether the creature is not, whether the creature is living things or non-living things. What do you mean motion is associated even with non-living things? Uh, Let me give you an example. Even non-living things has a kind of motion whenever you observe them under the microscope. Their particles, their molecules, their atoms are in continuous motion. That's why actually motion is associated with any creature in the universe. This is an introduction for this lesson before I dive in with the lesson. And it's a summary of the previous lesson. Right now, we are going to explain the new subject, which is the frame of reference. Let me read the definition of frame of reference. After that, I will break it down for you. So, frame of reference is a coordinate system for specifying the precise location of objects in space. Coordinate system for specifying, for designating, for identifying the precise location, exact position of objects in space. Right. This is called frame of reference. Any coordinate system, any location is considered a frame of reference. Right? A coordinate system like Cartesian coordinate system in mathematics actually is considered a frame of reference. Even this screen is considered a frame of reference, right? Uh, your classroom is considered a frame of reference for describing your motion, for determining the location of the students within the classroom, right? So they are all frames of reference. Keep in mind that frame of reference simply is a location where the motion is occurred. It's a location where the uh, where the motion is taking place. This is called frame of reference. Right. So, what's the purpose of using frame of reference? It's mentioned in the definition. The last part of the definition mentions the purpose of using frame of reference. So, purpose of using frame of reference is identifying the precise identifying the precise position of an object, identifying the precise location of an object, and describing the motion of the object. Actually, frame of reference is the first step and is sufficient for describing the motion of the object. Describing the motion of the object requires some steps. The first one is frame of reference. Right. Here we have an example. There's a gecko. Gecko actually moves from starting point to a final point. That's why it moves along an x-axis. It moves along the x-axis to the right. This is so. What's the convenient frame of reference for designating the position of the gecko let's say whenever it moves. So this meter stick is considered a convenient frame of reference. Whenever you put a meter stick under the feet of the gecko, you can designate the position of the gecko at each time, right? Or for especially for insects and for some small, let's say, creepers like gecko. Gecko is a reptile; it's not insect, but it's a let's say small animal, a small creature. That's why we can use even emitters. We even we can use even a ruler measuring stick, actually measured in Martin centimeters. You can use this one for describing the motion of the gecko, uh, and you have to place the meter stick or ruler under the feet of the gecko parallel to its motion. So in this situation, uh, meter stick or ruler serves at the x-axis. Maybe you say, teacher, what happens when the gecko moves along a tree trunk, right? In this situation, actually, you have to place the meter stick or ruler along with the y-axis parallel to the motion of the reptile of the gecko, and you can use it for any insect, whether the insect, it doesn't matter whether the insect is ant or let's say housefly, anything. Actually, we can use the meter stick or for these cases actually for small insects we can or for small reptiles we can use meter stick or ruler, right? So this about the for example this about the example of frame of reference. I prepared two notes for you. Note number one, in the figure above, about the figure, regarding the figure, the measuring stick is considered the frame of reference. The meter stick or measuring stick is considered a frame of reference. Number two, the measuring stick serves as the x-axis, as I told you. This measuring stick or meter stick is considered, let's say, it serves or considered x-axis. Right. Let's move on to another. Uh, let's keep going the explanation the of frame of reference. I'm gonna show you another, let's say, subject uh, has to do with the frame of reference. So frame of reference in general is of two types. Either we have stationary frame of reference or movable frame of reference. So there are two types of frame of reference: stationary or static, or motionless or stable. All of these names are used uh, let's say stationary frame of reference, or a static. We can say static frame of reference. This is the first type of frame of reference: stationary or motionless frame of reference, such as what? Such as train stations, bus stops. Train stations, bus stops are considered convenient frame of reference, convenient stationary frames of reference for describing the motion of the trains and buses. Right. The second kind of frame of reference is called movable frame of reference or mobile frame of reference means or movable, such as trains, cars, etc. in motion. Trains, cars, buses in motion. So moving objects are considered frame of reference as well, right? So you are free to choose the frame of reference. Choosing the frame of reference for designating the location of object and describing its motion is arbitrary. It's optional, right? But we prefer the motionless than the mobile. Motionless frames of reference and nearer actually nearer, closer frames of reference are more convenient than mobile and far frames of reference. Right? So actually, I told you, choosing the frame of reference, whether it's motionless or movable, it doesn't matter. It's optional. It's it's up to you, right? Whether you choose, let's say, mobile or motionless, it doesn't matter. Uh, but our purpose is making the interpretation of motion easier for us, right? For ourselves. We want to interpret the motion in a in easiest way actually. That's why in order to achieve this goal, you have to choose the let's say easier frames of reference. I mean static frames of reference and near frames of reference are let's say more convenient than movable and far frames of reference. Right. So here I prepared some tips for you. We have two tips. Let me read the tips for you. Number one, in physics, any frame of reference can be chosen. Right. Any frame of reference can be chosen. It's quite arbitrary. It's up to you. But near and stable frames of reference can make explaining things easier. Near, I mean, I highlighted the near and stable. Near and stable frames of reference actually can make the interpretation of motion easier for us, right, than far and movable ones. Than far and movable. So we prefer, let's say, static and near frames of reference. Let's say two. We prefer actually static and near frames of reference to the movable and far frames of reference. Number two, if an object is at rest means motionless, anything that does not move. If an object is at rest, motionless object, its position does not change with respect to a static frame of reference. If an object is at rest, its position does not change with respect to a static frame of reference. Teacher, what do you mean by this? Could you give us an example for uh, understanding the subject? Yes, no problem. I'm ready to give you an example. What does it mean? If an object is at rest, its position does not change with respect to a static frame of reference. Think about the train station, right? So train station itself is considered a static frame of reference, right? So we have a static frame of reference, which is the train station. And think about the benches that are installed on a platform of the station, right? There are some benches for sitting the passengers, actually. These benches are located on the platform within the station. That's why these benches are at rest. The benches are at rest, and the train station is at rest as well. So the location of benches does not change with the let's say with respect to the train station, right? So anything let's say is at rest does not change with respect to the static frame of reference. This is a let's say good example for understanding the subject. Here I'm gonna finish the lesson. Thank you very much for watching this video and see you next lesson.